5 insane facts about black holes. Black holes. Just the name sounds terrifying. These things are so powerful, so bizarre, so utterly incomprehensible, that even the world's smartest scientists are still trying to wrap their heads around them. And the more we discover, the stranger they get. We've launched telescopes into space just to catch a glimpse of one. We've dedicated entire careers, entire lifetimes to understanding them. Some of the greatest minds in human history have stared up at the sky and asked the same question. What exactly are these things? And every single time we think we have the answers, they surprise us again. Black holes don't play by the rules. They bend physics, they warp reality, and they make everything we thought we understood about the universe feel small and uncertain. And trust me, what scientists have found will genuinely shock you. So sit back, because today we're diving deep into the most mysterious objects in existence. Here are 5 insane facts about black holes. Fact 1. Time slows down. Okay, this one will genuinely mess with your head. And I mean that. Because this isn't science fiction. This is real, proven, measurable physics. The closer you get to a black hole, the slower time actually moves. Not metaphorically, not poetically, literally. Time itself slows down. This phenomenon is called gravitational time dilation, and it was first predicted by Albert Einstein over 100 years ago in his theory of general relativity. At the time, people thought he was out of his mind. The idea that gravity could stretch and compress time felt absurd, but decades of experiments have since proven it's completely real. We've even measured it here on Earth. Clocks on the ground tick ever so slightly slower than clocks on satellites in orbit, because they're deeper in Earth's gravitational field. Now imagine that effect cranked up to an almost infinite degree. If you hovered near a black hole for just 1 hour, years would have already passed back on Earth. Not days, years. Your friends would have aged. Your family would have aged. Entire political systems could rise and fall. Children could be born, grow up, and have children of their own, all while you experience just 60 minutes. And the most chilling part of all, you wouldn't feel a thing. No tingling, no warning, no indication whatsoever that time around you has completely broken down. You'd just be floating there, completely unaware, while the world moves on without you. Fact 2. They're not actually black. Here's something that almost nobody tells you. Black holes aren't even black, I know. The name is spectacularly misleading. And honestly, whoever came up with it probably should have thought it through a little more. Yes, at the very center of a black hole is a region called the event horizon, the point of no return, where gravity is so intense that not even light can escape. That part is dark, completely dark. Nothing gets out, but surrounding it, pure, violent, blinding chaos. Superheated gas, dust, and matter get pulled toward the black hole from all directions, and as they spiral inward, they form what's called an accretion disk, a swirling ring of material that moves at nearly the speed of light. The friction and compression in this disk heats the material to absolutely insane temperatures. We're talking billions of degrees, not millions, billions. At those temperatures, the disk glows ferociously, blasting out enormous amounts of light, X-rays and radiation in every direction. Some black holes are so luminous that they outshine entire galaxies containing hundreds of billions of stars. These are called quasars, and they are among the most energetic objects ever observed in the universe. So the next time someone pictures a black hole as just a dark, quiet void floating in space, gently let them know they couldn't be more wrong. These things are screaming with energy. Fact 3. Spaghettification. This one is exactly as horrifying as it sounds, and I want you to really picture this because it's one of those things that sounds like it was made up, but is devastatingly real. Imagine you're falling toward a black hole. As you get closer, gravity starts pulling on your feet, harder than it pulls on your head, because your feet are slightly closer to the source of gravity. On Earth, this difference is so tiny you'd never notice it. But near a black hole, the difference becomes extreme, catastrophically extreme. The pull on your feet becomes so much stronger than the pull on your head that your body starts to stretch. First your legs elongate, then your torso, then your arms. The gap between every atom in your body is being forcibly widened by tidal forces so powerful that nothing, no material, no substance, no structure in the known universe could resist them. You are being pulled apart at the molecular level, stretched thinner and thinner and thinner, like someone pulling a piece of chewing gum until you are nothing but a long, impossibly thin strand of matter spiraling into the void. Scientists call this spaghettification. That is the actual, official, peer-reviewed scientific term, spaghettification. And here's the truly terrifying twist. The timing depends entirely on the size of the black hole. A smaller black hole has a more concentrated gravitational field, meaning the tidal forces near it are extreme even at a distance. You'd be torn apart before you even got close. But a supermassive black hole, the kind that sits at the center of galaxies millions or billions of times the mass of our sun, has a much more gradual gravitational gradient, meaning you could actually cross the event horizon, the point of no return, completely intact. You'd float across it without feeling anything unusual at all, and only then, as you drifted deeper inside, would the tidal forces gradually begin to build, and you'd slowly realize there was absolutely nothing you could do about it. Fact 4.1 is only 1,000 light years away. Now here's the part that should make you just a little bit uncomfortable. For most of human history, we assumed black holes were safely distant, exotic objects lurking in the far reaches of the galaxy, thousands or tens of thousands of light years away. Nothing to worry about. Just an interesting curiosity. Then, in 2020, a team of astronomers made an announcement that quietly unsettled a lot of people in the scientific community. They had found a black hole, a stellar mass black hole, sitting inside a system called HR 6819, and it was just 1,000 light years from Earth. Now, before you panic, and I want to be very clear about this, it poses absolutely zero threat to us. At that distance, its gravitational influence on our solar system is completely negligible. We are in no danger whatsoever. But let's just put 1,000 light years into context for a moment. Our Milky Way galaxy is approximately 100,000 light years across. So this black hole is sitting in just the first 1% of our galaxy's width away from us. In cosmic terms, that is our immediate neighborhood, our backyard. And here's what's even more interesting. Astronomers now believe that there could be hundreds of millions of black holes scattered throughout our galaxy alone. Most of them we simply haven't found yet because they're dark, quiet, and not actively consuming anything. They're just out there, floating silently in the dark, which raises an interesting and slightly unsettling question. How many more are closer than we think? Fact 5. They eventually die. As terrifying and all-powerful as black holes seem, I want to leave you with something that is equal parts comforting and mind-bending. Black holes are not immortal. They die. In the early 1970s, a young physicist named Stephen Hawking sat down and started combining two of the most complex branches of physics, quantum mechanics and general relativity, to think about what happens right at the edge of a black hole. And what he found stunned the entire scientific world. He discovered that black holes aren't perfectly sealed. Due to quantum effects happening right at the event horizon, black holes actually slowly emit tiny amounts of radiation and energy over time. This became known as Hawking radiation, and it was one of the most significant theoretical discoveries of the 20th century. Now, the rate at which this happens is almost incomprehensibly slow. A black hole with the mass of our sun would take around 10 to the power of 67 years to evaporate. That's a number so large it makes the current age of the universe look like a rounding error. But here's the thing. It happens. Bit by bit, particle by particle, a black hole bleeds energy into the universe, and as it loses mass, the process actually accelerates. The smaller it gets, the faster it radiates, until eventually, in a final brilliant flash of energy, it's gone. Just like that. After trillions upon trillions of years of bending space, swallowing stars, and defying everything we thought we knew about physics, it simply disappears. Even the most powerful things in the universe eventually come to an end. And somehow I find that oddly beautiful. Black holes are, without question, the strangest, most terrifying, and most fascinating objects in the known universe. And what's truly humbling is that everything we've covered today, every single fact, was completely unknown to humanity just a few hundred years ago. We are living in an era where we can photograph black holes, measure their gravitational waves, and calculate how they'll eventually die. And yet for all of that, we still have so many unanswered questions. What happens inside the event horizon? What is a singularity really made of? Are there black holes larger than anything we've ever imagined, hiding in the furthest corners of the universe? Every answer we find just opens up 10 more questions.